It is my distinct pleasure to be introducing all of you to James, who is, I was chatting with James a little bit, like, because I saw that he's a contractor, and like, you know, my first 15 years I was a contractor, so it's always interesting to hear experiences from folks. James has maintained loads of popular Clojure libraries, and he's going to be talking to us about a topic that is near and dear to my heart, which is working with legacy code. So you don't have to hear it from me, folks. Give it up for James.
Hello. Testing. Okay. So I'm James Reeves, as I was introduced. My username is Weavejester. It's been 5 years now since I've given a presentation, so I'm a little bit nervous, especially considering the caliber of the presentations this year. They've all been amazing. I was sitting in the audience thinking, if you could be a little bit worse, I'd feel a little bit better at mine. So this talk is also a little different. I usually give talks about things I'm proud of or that I think would be useful for other people. This is a talk about my mistakes. This is a talk about things I've done wrong and things that are difficult or impossible to fix, things that I need to live with. Welcome to Living with Legacy Code. So I mentioned this was about my mistakes. A better way of putting it is that this is an open source retrospective. This is a look at things which could be been done better and how to live with the consequences of things that we can't change. So I want to invite you back all the way to the year 2009. Get in your favorite time machine and come back with me. This is the year that it's just after Clojure had come out. I think a couple of years after the iPhone, during the financial crash. Come back with me. And this was when I was in my mid-20s. So looking back at it, 15 years doesn't seem like a long time, but when I think of how young I was back then, it really does. So I was looking to create something in Clojure. It just come out. I wanted to create web applications. So I created something called Compojure. And back then, it wasn't a routing library, as it is now. It was a full, all singing, all dancing web application based on Java servlets. It was the Rails, as I kind of thought of it, or at least the beginnings. But then Mark McGranahan approached me and he suggested splitting it up. He said, I've been working on a project called Ring, and this would be like an agnostic layer for Clojure for web applications, similar to Ruby's Rack. And I thought, well, at first I took a little bit of convincing. But then it turned out that, yes, this was a good idea. So Compojure got factored out. Ring became, or Compojure Jetty and Compojure HTTP became Ring, and Compojure HTML became Hiccup. And this is what I want to talk about. So that's Ring was in collaboration with Mark McGranahan, and Hiccup was based on earlier work in Lisp. And we're going to talk about Hiccup first. So what is Hiccup? There we go. Yep. Hiccup is HTML in Clojure. So to explain what that means, here we have some HTML. We have a span class, we have a span tag, we have a class, we have some text. This is HTML. And Hiccup represents HTML in Clojure data structures. So it looks a little bit like this. Instead of the tag, we have a keyword at the front. We're using vectors to represent the full tag. And we have a map in the second position, which represents the attributes of the tag. And Hiccup converts the bottom into the top. So then Mark McGranahan, again, he approached me a little bit later with something he created called CLJ HTML. And the advantage that CLJ HTML had over Hiccup was that it was pre-compiled. And he said, well, instead of having two separate projects which broadly do the same thing, how about you roll my performance optimizations into your library, and then we can like joint maintain it. And I said, well, this seems great. So let me explain a little bit what pre-compilation is and why I thought it was so good. So pre-compilation takes something at the top and it converts it into something at the bottom. So the top line of code, we have the HTML macro, which is the whole thing which runs it. And we have a bunch of literals. So we've got a keyword literal, we've got a map literal, we've got a string literal. And then we've got a user, which is a symbol and not a literal. So because we've got so many literal values in here, we can actually just pre-compile this into a string. We can convert the top into the bottom. And that way we don't need to do so much dynamically. At runtime, we just need to concatenate strings together. And concatenating strings together in Clojure is pretty fast. Behind the scenes, it's a string builder. This takes around about a few hundred nanoseconds to complete, which is a lot faster, around about 10 or 20 times faster than actually going through the vector itself. So this is the ideal circumstance. You can also get a circumstance like this, where you don't have the attribute map. And in this case, we have to essentially have a conditional here, because we don't know whether user is a string, another tag, or whether it's an attribute map itself. So, because it could be a map, because it could be a set of attributes, it compiles to this here, where we first check whether the user is a map, and if it is, we render it as a bunch of attributes. Otherwise, we put it in there, and I've realized I've put username instead of user, so ignore that. I mean, this whole talk is about mistakes. There's one right now. Finally, we could just pass user directly to HTML. In this case, the macro has no information at all. It could be anything. So in this case, it just passes it to a function, render HTML, which does it all dynamically. So the advantage of pre-compilation is that where we have literals, we can build them into strings to make the dynamic calculations easier. We can push the calculations that normally we do at runtime to before we even compile it, to the macro expansion phase. So runtime rendering, because we fall back to runtime rendering, it means there's no downside to pre-compilation. There was a downside to pre-compilation. So the kind of main downside is that the HTML macro can't look into other functions. It can, because it's a macro, it can see what's, okay. Because it's a macro, it can see its own body, but it can't see what's actually inside the function there. So warn is effectively a black box to it. It knows that warn is some kind of function, it doesn't actually know what's inside it, so it can't optimize what's inside it either. Which means that if we want to make this warn function run performantly, we need to wrap its contents in a HTML macro as well. And this has some consequences, because it means you have to return a string. So all of this was fine initially, blissfully going on to 1.0, not realizing that there were any potential problems here. And then multiple people, in fact, came to me and said, well, how are you handling escaping HTML? And let's explain this a little bit. So we have some code here. We've got a username, we've put it into a span, and we get out some HTML. All well and good. But then if your user looks something like this, you have a problem. The HTML that's untrusted gets into your code, and then bad things happen. You can't trust user data, you need to escape it. Same for SQL, same for HTML. Now, there is a function, escape HTML, in Hiccup that will escape the HTML. And this can be shortened to H after something that's a similar function that's in Ruby. So that's all well and good. We've escaped the function. It's all okay. It's secure. But you have to remember to do this. And if you forget to do it, there's no type checker that's going to tell you that you've forgotten. So we've got a security problem that kind of relies on the programmer remembering to put all of these things in, which isn't really the best solution. I mean, as programmers, we know that we make mistakes. And ideally, when we make mistakes, our compiler should tell us, or our tests should tell us that we have made the mistake. If it gets to production, bad things happen. So thought about how to do this in Hiccup, and because of the pre-compilation, I already had this idea that you needed to return a string, because we needed to be able to put HTML into the functions. We need to pre-compile all of these functions, and because you needed to have multiple pre-compilation steps, it all needed to be strings. But we also want to escape strings. So we have like a problem here. We essentially have strings from Hiccup, which we know are safe, and strings from the user, which may be unsafe. So the solution to this was to split it up. So we have a raw string class that's unescaped that Hiccup can use, and a string class that the users can use. So the bottom part is safe, and we can just include that. The user data can run from there. And the top is unsafe, and that's only for internal use. So okay, that's a solution. And this is a type signature of Hiccup 1.0, where we have the HTML macro taking in some persistent vector, Hiccup code, and producing a string. Then we change this to produce a raw string in Hiccup 2.0. So more generally, it looks like this. Hiccup, you have the HTML macro, which turns this span into a string. In 2.0, it turns it into a raw string, which means that you need to wrap it in an additional toString call to turn it back into an actual string. So it's a similar API, but slightly different. So 2.0 went into alpha version, and this was escaped by default, so it was a lot more secure than 1.0. But was this really the right solution? Because initially, the original goal of pre-compiling this was to opportunistically increase performance without changing the API. And we've changed the API because it now produces a raw string instead of a string, and we've got to convert it back. So it's never really sat right with me. And as issues like came in, as Hiccup was used in more projects, we found other problems as well. We found that there is a method instruction limit to Java, which I didn't know until actually writing Hiccup. There is a limit to the amount of instructions you can have in a single method. And if you have a large set of Hiccup code, particularly one that's quite complex, it generates a lot of additional code that hits this limit. And you've either got to split it up, which is unoptimal, or you sort of like try to dynamically render it. It's also hard to change formatting. So because everything is pre-compiled, it's hard to go in and say, well, actually, we want things to be formatted, pretty formatted, instead of formatted all as without indentation at all. So switching from indentation to a compact view is hard if you're pre-compiling it. So these were generally problems that we had, and things that broke the original contract we had, which was we want this to be transparent to the user. So how do we solve this better? I'm going to pause here because there's only a limited amount of time that we had to actually solve it. Because remember, Hiccup 1.0 was out there. It was a stable version, but it was also insecure by default. And ideally, we want people to use something that's secure by default, but we weren't happy with the API. I use the word we out of habit, but it was really me. So I delayed putting out a stable version of Hiccup 2.0 because I was unhappy with the API. And it all stemmed from the idea of trying to maintain performance. But people started using the alpha version. And this is kind of one of the central principles that I sort of discovered, is that you can only delay your alpha version so long before it becomes your de facto 2.0, right? Your de facto stable. People will use your alpha version and treat it as stable if you keep some software in alpha for long enough. So also takeaways is that abstractions may be not as watertight as you think. So when we started it, we thought pre-compilation, it's fine. We can fall back to dynamic rendering whenever there's a problem. But it turned out it wasn't as watertight as we thought. And abstractions may become leaky when requirements change. In this case, the requirement to add escaped HTML caused the leaks. So let's look at the other side of that family tree now. Let's leave Hiccup behind, and let's take a look at Ring. So Ring is a web server abstraction, similar to sort of Ruby's rack. Ring represents HTTP requests and responses as normal Clojure maps. So this is a Ring response. Many of you will probably have seen this before. And originally, the keywords we had were unnamed space. These are just like raw key spaces, raw keywords. In Clojure, you can actually namespace the keywords. And namespacing keywords in this case is a better design because these represent unique names. If I just put status as a keyword, it can be it can refer to any status. It's not necessarily a status of a HTTP response. It could be a status of some internal API. Whereas if we have Ring response status, we know that it refers to a Ring response. So this is a more unique and more descriptive way of handling it, and we can add specs to it. We can dynamically type it, which we can't really do with an unnamed space keyword. So this is like a better design. And later on, as Clojure evolved, this rather kind of long syntax got lots of sugar. So you can now, in modern versions of Clojure, write the previous version like this. And we can even alias it using require in order to get an even shorter representation of it. So this was really the right way of doing it, and the wrong way of doing it was to use unnamed space keys. At the time, we didn't really know any better. We were still exploring stuff. So Ring 1.0 came out in 2011. And around about the year of 2022, I wanted to introduce WebSockets to Ring. So there have been multiple WebSocket implementations in various like third-party adapters. I had held off on it because I didn't really know how to design it. And then eventually we got a design that we're happy with. I sort of published it to the community. They seemed to be all okay with it. I talked to various various people who maintain third-party adapters as well. And we eventually wrangled down a broad solution. So I thought, okay, Ring 1.10, let's introduce WebSockets to it. However, there is a problem. Because what syntax do we use for the keyword? We could use the above syntax. We could say use an unnamespaced keyword, WebSocket listener. That'd be consistent with the existing keys, but it wouldn't be unique. Or we could go for the bottom one. We could actually have a namespace keyword, which is the better solution in isolation, but it would also be inconsistent with all of the ring keywords so far. So what's the solution to this? So I went back to the drawing board and I said, well, let's do a ring 2.0. Let's fix all of the issues in ring 1.x, and let's create, let's update the maps. So let's go update the response and request maps, and let's make them namespace keywords. And then we can implement WebSockets, and it'll all be nice and consistent. However, this might mean a breaking change. And I just watched Rich's talk, Speculation, where he talked about having attrition or having accumulation in our software projects, not breaking things, but instead accumulating feature after feature. So I thought, well, do we need to actually break things? Is there any way around this? Because Ring is used by a lot of projects, and any breakage in Ring is going to be felt by a lot of people. What could be a 5-minute change multiplied by, say, 1,000 people turns out to be some significant developer time. So ideally, I wanted to avoid this. One way of avoiding it is to have 2 different namespaces. You have a Ring and a Ring 2, and in theory, you can have one thing that uses another thing. And this was the approach I took in Hiccup, where I've got Hiccup and Hiccup 2 namespaces. But there were some slight differences between Ring 2.0 and Hiccup 2.0. In the case of Hiccup, you have the same data structure. The data structure didn't change. And the only thing that changed was the API. And the Hiccup API is fairly straightforward. It's just a single macro, HTML. In Ring, there is a much larger API. And the problem was that we were changing the data structures. So we weren't just changing how the API more or less stayed the same, but the data structures is how we interacted with third-party libraries. So by changing the data structure, we break a lot more than we do with Hiccup. And I was trying to think of ways of getting around this, of having my cake and eating it too. And one of the ideas I played around with was, well, we can test to see whether or not a request and a response is Ring 1.0 or Ring 2.0, and therefore we can have middleware that works with both systems. So that's kind of a solution. We can also have functions that take in a handler that works with Ring 1.0 and turn it into a handler that works with Ring 2.0. So we can automate the upgrade process in some way. But despite all of these solutions, we can't eliminate breakages entirely. So I thought quite a long time about this, maybe like a year or so. And eventually, I decided that this just wasn't going to work. There wasn't any way of breaking it, and really the amount of code we kind of need didn't seem worth changing the keywords. Like, it's a fairly minor change. Yes, it's producing requests and responses that are more unique and more identifiable, but the amount of work behind it felt onerous. So Ring 1.0 came out as more or less a minor update, just to pull in all of the pull requests that had been piling up during this time. And then I decided to kill the 2.0 branch. And instead, 1.11 would use WebSockets. And the solution I eventually settled on was a compromise. And that was to use the old response, use unnamespace keywords with the old response, so keep the keys the same, keep everything compatible, and then with the WebSockets to use the new namespace keys, which is objectively better but inconsistent. So this was a compromise. but I think it represented the best solution overall. It meant that people didn't have to rewrite their code. It means that going forwards, any new keys that we introduce are identifiable. It's a shame about the old keys, but I think that's a mistake that we need to live with. So, talking about mistakes we need to live with, all of these happened quite early on. So these mistakes happened in 2011, 2009, and you would have thought that since my mid-20s, I might have learned something. I might be less able to make mistakes. So let me introduce you to Medley. I don't want you to get the impression that these just happened in the past. I want you to have the full picture and understand that even in 2021, I screwed up. So I want to talk a little bit about Clojures now. Clojures is where the repository, where the artifacts of libraries are stored. And back in the day, we essentially had like two ways of naming artifacts for libraries. So we had the first approach, where we name, just use the group name as the same as the artifact name. So with Clojures is compatible with Maven, and Maven expects you to have some kind of group name to explain a library, and some kind of actual name. So in this case, we have a group name called Medley, a name called Medley. This was the name of the library. And in Leiningen, you could actually just call it Medley. And if you put that as your project name using Leiningen, it will produce a project that has a group name the same as the actual artifact name. So this is one way of doing it. And the advantage of this approach is that it's not dependent on any domain names. So if the domain name changes, you've still got the same project name. And as we'll find out, that's kind of useful to have a project name that doesn't change. The other way of doing it is to have some kind of reversed domain name as your artifact name, as your group name. So in this case, we have dev.weavechester, which is a reverse domain name of weavechester.dev. And some people used the top format and some people used the bottom format, but in 2021, Clojures, as a result of security concerns, decided that the top one was to be made obsolete, and the bottom one was the canonical way going forwards. So all new libraries would have to use the bottom one. All existing libraries could use the top system. Pardon me. There we go. So I decided to change how Medley, the group name, worked. I went, okay, well, this is great. We've got a consistent naming scheme now, which has been decided on by all high. All new libraries will use this naming scheme going forwards. Great, let's go through and change all my existing libraries to use the old system, or to use a new system, and then everything will be consistent. So I did this with Medley. The old Medley version became obsolete, and I changed the name to dev.weavechester.medley. So I thought, great, this is perfect. This is a system that this works with the new convention. And I can just do this to all my libraries, and then everything will be a consistent convention. Unfortunately, it also breaks compatibility, which is something that seems obvious in retrospect, but at the time I didn't think of. In that if you have two libraries with two different names, then Leiningen, or whatever dependency mechanism you're using, deps.eden, for example, doesn't know that these two things are meant to be the same library. And if Medley is like a dependency of a dependency of a dependency, you may get into a situation where you have two Medley dependencies coexisting of two different versions, without the dependency tracker that you're using realizing. So this causes problems. Basically, you have two namespaces which are fighting for the same system. It's going to cause a whole bunch of issues. And unfortunately, there's no way back from this. It took me a few weeks to realize this, as like issues poured in of like people saying, wait, this is breaking stuff. And there was really no solution. I went to Clojure's and I was grateful that on the issue request, other people had run into the same problem. But there was no real solution to this, because I could go back to the original Medley/Medley, but then that would break things for people who had started using dev.weavegester/Medley. I could continue with dev.weavegester/Medley, and then hope that the people using the old version gradually switch over. But I couldn't think of a way of, and I don't think there is a way, of preventing this breaking change. Once I had committed this, once I had pushed it to Clojure's, that was it. So the problem isn't fixable. So let's go with our conclusions. What can we learn from our mistakes? And by that, our mistakes, I mean, what can we learn from my mistakes? First of all, you have to release sometime. Or someone else will. If you're not going to release something, somebody else will produce a library that does something similar to yours and will release that. There is like a time limit on any library that does something useful. Either you release it, somebody else will, particularly in the open source community. Or if you just keep your version at alpha or at unstable, your alpha will become your de facto stable. At some point, people want a stable library. People will start using your library as stable, and you can mark it as unstable as much as you want. But if it's a useful library that people want to use, people are going to use it. And they're going to treat it as if it were stable. Secondly, you will make mistakes. It's just a fact of life. I make mistakes. Probably everybody here has at least made one mistake, I hope. It's something that's unavoidable. Because we have time constraints, we can spend as much time as we want, but eventually we need to produce something, and we will not have thought of everything. The other thing I want to impress is that old and new systems can coexist. All of our infrastructure, our physical infrastructure, kind of operates on this principle. We have older trains and newer trains. We have sort of older roads which follow paths of which were never designed for motor vehicles. And we have to just live with the idea that we have some archaic layer that we're building on top of. And these can exist as separate structures. So we can have old structures existing beside new structures, and this is a kind of metaphor for having different namespaces. We can have our 2.0 in a separate namespace, in a separate package to our 1.0, and as long as we maintain both of them, as long as they're separated and we can have both in the same project, this is fine. Alternatively, we can add new things to existing structures. And this is a metaphor for using the same functions in the same map. So in the case of Ring, we can use unnamespace keys and namespace keys in one map. We can use the old and the new in a single data structure. So overall, we should prefer compatibility over consistency. This is a hard lesson for me to learn because I really, really like consistency. And this is especially true if breaking things would create a lot of work for a lot of people. If you've got a library that is used by a lot of people, then any small breaking change you make is going to compound itself. There's going to be a lot of people who will have to look at the changes you've made and update their own product. And they often are doing other things as well. Like, they're not going to thank you for making a lot of these changes. Most of the time they're going to say, well, it's really annoying that I have to update all of these things because this person decided that this way was better. And that's the end.